Hi everyone. In this video we are going to learn to isolate a variable in an equation with more than one variable. So let's start with A. It's going to start basic and work our way up. So in A we have the area of a rectangle formula, which is A equals L times W. Remember, if they're written right next to each other, that means multiplication. Okay, so you think of a rectangle, that's length times width to give you the area. Now, anytime you're struggling with a problem with multiple variables, you can always take it back to a problem that you should know how to do with numbers. So if I had 10 equals -5 times w, and I wanted to solve for w, what would you do? So you want to get this w alone. That means you have to get rid of anything bothering the w, which is what's attached to it is a -5. So this is -5 times w. To undo multiplication, you would divide both sides by -5. Okay, because -5 divided by -5 is 1, so that cancels out. And 10 divided by -5 is -2. And then w is alone and you're done. Okay, so this problem is very similar, except you have variables instead of numbers, but the process stays the same. So if you, again, want to solve for w, you got to get rid of whatever's bothering the w, which in this case, instead of it being -5 times w, we have L times w. So I want to get rid of that L. Okay, so if it's L times w, I need to undo multiplying by L. What undoes multiplying by L would be dividing by L. And whatever you do to one side, you're going to do to the other side. So anything divided by itself cancels. Like -5 divided by 5 is 1. L divided by L also cancels because L divided by L is 1. So on this side, you're just left with W, but whatever you did to one side, you have to do the other. So on the left side, I have A divided by L, and that is equal to W. So the only difference between these two problems is this one, you'll actually get a number as your answer. Whereas if you have more than one variable, you're not going to be able to get a concrete numeric answer. You're going to be left with an equation as your answer, and that's okay. Okay, so I'm going to let you try B on your own. Pause the video. I'll come back with the answer. No peeking. Okay, if you did part B correctly, you should get S equals P over 4. So again, you're trying to solve for S. You're doing 4 times S. To undo that, you divide by 4. Whatever you do to one side, you do to the other. And at the end, you have an equation. Okay, let's try a different kind of equation with the same idea. So in this case, we're going to deal with our profit formula. Although it looks kind of different, which we'll get to in a second. But before we get there, let's start with a numeric answer and remember what we would do here. So if I want to solve for P, I have to get rid of everything that's bothering the P. So right now we have P plus 200. And I want to get P alone, so what undoes addition? I'd have to subtract 200 from both sides. Whatever you do to one side, you have to do to the other. Keep repeating myself because it's important. So 200 minus 200, that gives me 0. That's why that cancels. And then on this side, you have 500 minus 200. Since those are like terms, you can combine them and get 300. Okay, so I get P equals 300. Now, if I want to do it to my equation with variables, I got to do the same thing. So I'm trying to get P alone. If you look at the side with the P on it, what is bothering the P? That's the C. So I have P plus C. How do I undo adding C? I would have to subtract C. Just like I did in this equation over here, I subtracted 200. Now, C minus C gives me 0, which is why those cancel. Okay, the only difference is I have an R and a C here, which I cannot combine. Okay, so I'd have to, just leave them as R minus C or as an equation. So then I have P alone, so P equals R minus C. How is this the profit formula? Well, it's profit equals revenue minus cost. And this formula is equivalent to this formula. Equivalent means they're the same, just written in different forms. Okay. Now, C is a little bit different, but I'm going to leave it for you to try alone as well. Your goal is to solve for T, so you got to get rid of everything that's bothering the T. I'm going to let you try this on your own. Pause the video. Okay, so I want to kind of talk through one thing about this problem is I can see how most people might start by just dividing by, say, P. Okay, because you want to get T alone. It's P times R times T. What undoes multiplication is division. So you might divide by P, and that cancels a P from this side. The only problem is that our T is not alone then because I still have the R. So if you just try to do that and then you got stuck, there's probably a better way. So although this is not incorrect, it's just not a complete answer. So I'm going to erase that and talk about what I did instead. And if you take a look to the right here. So this is P times R times T, which means they're all being multiplied. And the only thing I want to be left on the right side here is the t, which means I need to get rid of both the p and the r. The p and the r are both multiplying with the t, and to undo both of those, I need to divide by both of those. So if I divide by p and r, the p's cancel and the r's cancel, so you'll just be left with t. Whatever you do to one side, you need to do to the other. So I have I divided by pr, and that's going to be your final equation. Again, there's a lot of variables, and it's not necessarily pretty, and that's okay. You should have an equation at the end. Okay, next one's really, really important because we're going to deal with a lot of this thing over here throughout the semester or the year, and that's lines. So this is the equation of a line in standard form, and our goal is to solve for y. Okay, so before we do it with variables, again, I want to deal with numbers because the steps are exactly the same. You just have more variables on the left. So if I want to solve for y, I got to get rid of everything that's bothering the y. So anything that's on the y side that's not the y, I got to get rid of. I'm going to get rid of the 3 and the negative 6. Okay, but in order to solve this, anytime you solve an equation, you guys remember PEMDAS? Well, we actually work backwards to solve an equation. So you have to take care of addition or subtraction first, then multiplication or division, then exponents and parentheses. So addition or subtraction comes first. So where do you see addition or subtraction here? Okay, so I have negative 6 plus 3y. So you're actually adding this negative 6 to the 3y. But I got to undo negative 6, which is like a minus 6. So what undoes a minus 6 would be a plus 6. Whatever you do to one side, you have to do the other of the equal sign. The reason that works is because you have a minus 6 and a plus 6, and minus 6 plus 6 gives you 0, so it's cancel. So on the left side, I just have 3y, but then I have to add 36 plus 6. Okay, so 36 plus 4 would give me 40, but there's 2 more, so it'd be 42. Okay, now this one's a little bit more complicated because it's a multi-step equation. My y is not alone yet. So now I have 3 times y equals 42. So how do I undo 3 times y? Well, division undoes multiplication, so I'm going to divide both sides by 3. Not 3y, just 3. The reason is because you want the y to still be on the left side here. So 3 divided by 3 is 1, or 1y, then the y is alone. Now I have 42 divided by 3. Well, 42 divided by 3 gives me 14. So then my y is alone. Okay, take that and apply it to this problem, which is very similar. The only difference is that you have more variables, but you still want to get y alone, so I got to get rid of anything that's bothering the y on the y side of the equation, which is this 3 and this minus 6x. Okay, just like you added 6 here, you're now going to add 6x here because you want to take care of that addition or subtraction first. Okay, so 6x and negative 6x, or minus 6x and plus 6x, those cancel each other out. They undo each other. So that's gone. So again, on the left side, I just have 3y, just like I did here. Now here's where the difference comes. You can add 36 and 6 together because they're just numbers. But 36 and 6x are not like terms. So you have 36 as a number, you have 6 x's, you can't combine those. So I'm just going to leave that as 6x plus 36. Okay, or if you prefer, it's the same thing as saying 36 plus 6x. It doesn't matter the order of these numbers. 2 plus 3 is the same as 3 plus 2. So addition you can do in any order. Okay, so now I have equation, but the y is not alone yet. So I have 3 times y, just like I did here. To undo 3 times y, I have to divide by 3. Whatever you do to one side, you have to do the other. So 3 divided by 3 is 1, so those cancel out. You have y equals, okay, so really you have to divide the entire equation by 3. So one way you can write it is this, and that was fine, which is what you see above there. Okay, or, another or, a better answer would be to simplify this. So what you really have is the 6x is being divided by 3, and the 36 is being divided by 3, right? That really long division bar means I'm dividing all of this by 3. So 6x divided by 3 is 2x. 36 divided by 3 is 12. So it'd be 2x plus 12. And now my y is isolated, and I went from a standard form of a line, and this should hopefully look familiar. It's kind of like, I don't know, y equals mx plus b. Yeah. Okay, so this would be my slope, this is my y-intercept, and that's why the skill is really important, is because if you can isolate the variable, this equation is a lot more useful to look at than this equation. So we're going to do a lot of transforming of equations of lines. So keep that skill in mind. And I think the moral of the story here is whether you're dealing with variables or numbers, the processes of solving an equation are always the same. Okay, so the process or the order you go through things, whether it's numbers or variables, you do it the same, even though it looks different. So don't let that confuse you just because it looks a little uglier. I'm going to leave E for you to try on your own. I'll come back with the answer. Okay, if you did this one correctly, you should get y equals 2/3 x plus 4. So all I did was move the x over. So then I have 2x and 12 that I added together. And then to get y alone, you divide by 3. So both parts are being divided by 3. However, 2 can't be divided by 3, so I just left it as 2 divided by 3. 12 can be divided by 3, though, and it's just 4. So you get y equals 2/3 x plus 4. And remember, this would be the slope, and this would be the y-intercept, which, again, this equation is a lot more useful than this form of the equation, which is why we need to learn to isolate variables. And as a bonus, you know this is the equation of a line. My question to you is, can you find two coordinates or ordered pairs which satisfy the equation? When I say satisfy the equation, that means make it true. Or two coordinates that are on the line. So once you have an equation, if you want to find something that makes it true, all you have to do is plug something in for one of the variables and get the y as the output. So for example, let's say y equals, let's say x is 3. So if I know x is 3, I'm going to plug it in for x here. So I have 2/3 times 3 plus 4. And if I solve this equation, it's going to tell me what y equals when x is 3. So what's 2/3 times 3? That gives us 2. So y equals 2 plus 4, which is 6. Which means when x is 3, our y value has to be 6. So one coordinate would be 3, 6. See if you can find a couple more on your own. And ask questions if you have them. Okay, I'm going to do one last problem, and then the rest are for you to do alone. So this one has some fractions and division, which is a little bit different from the problems we've done above, but same process. Okay, so let's just compare it to the one with numbers. Our goal is to get a alone. Okay, so if you want to get a alone, you have to get rid of everything bothering the a on the a side. So I got to get rid of this 1 and 4. But we're going to work in reverse PEMDAS, so like up here, we always did the addition before we did the division. We're going to do the same thing here. Do the addition or subtraction first. So this is a over 4 plus 1. To undo adding 1, I have to subtract 1 from both sides. So 1 minus 1, those cancel out. So I have a over 4 equals 3. Okay, now this is a divided by 4, but I want a alone. So what undoes division by 4? I'd multiply both sides by 4. If I multiply by 4 and divide by 4, they cancel. So I get a equals 12. And the process you go through here is going to be the same thing you go through here. So my goal is to get a alone. So I got to get rid of the c and the b. So just like I subtracted 1 here first, I'm going to subtract c first. Again, the only difference is that I can't combine these because they're not like terms. So I'm going to leave it as d minus c instead of doing 4 minus 1 and getting a number. Okay, so a is not alone yet because it's being divided by b. So to undo division by b, I have to multiply by b. So if I divide by b and I multiply by b, they cancel. Whatever you do to one side, though, you got to do to the other side. So a is going to equal, I've got to multiply this d minus c times b. Okay, the reason I put this in parentheses is because you're multiplying this entire side by b. Not just the d, not just the c, but everything gets multiplied by b. And by putting in parentheses, it groups them together. So you make sure that the b gets multiplied to both the d and the c. Which you can even write that in a different form. You can say a equals, well, b needs to multiply by d, so it's b times d. B also needs to multiply by this minus c, so that's minus bc. If you prefer in this form, that's good too. Okay, so that's how you isolate a variable in equations with multiple variables. I cannot stress this enough that it's going to be the same as if you're dealing with numbers. Okay, so there's some practice problems for you to try on your own, and then there will be more practice when you are done with that. If you have any questions, please ask your teacher.